Number 19, identify the graph and the polar equation. And we're given r equals to 4 times the sine of 2 theta. Well, since I have an r all by itself, and it's set equal to a function with a multiple of theta on the inside, this has to be a rose. Because all of our other functions either have an r squared or something being added or subtracted to theta. So this is definitely going to be a rose. And we can tell the number of petals a rose has by the number out in front of theta. So if it's an even number, we're going to have twice that number of petals. If it's an odd number, we're going to have the exact same number of petals. So this is an even number in front of my theta, so I have 2 times 2, or 4 petals. When we have a rose with an even number of petals, we're going to have to graph from 0 to 2 pi. Now what we want to do is test for symmetry and see if we can possibly cut this down, and hopefully we can. Usually we start out with our polar axis, and then we go on to the line theta equals to pi over 2. So for our polar axis, we're going to take theta and replace that with negative theta, and then simplify our equation as much as we can. So we're going to have r equals to 4 times the sine of 2 times negative theta. Well, it's going to give me r equals to 4 times the sine of negative 2 theta. And then since sine's an odd function, that negative will come out to the front. Well, unfortunately, it does not meet the conditions that we have for symmetry. Now, there may still be symmetry there, we just can't check for it, unfortunately. So let's check for symmetry at the line theta equals to pi over 2. So for this one, we're going to replace theta with pi minus theta. So r will equal to 4 times the sine of 2 times pi minus theta. And of course, I'm going to simplify. So it's going to give us 4 sine of 2 pi minus 2 theta. Now, I want to get rid of that angle on the inside of my function. If we remember, I can add or subtract 2 pi from the argument of any of my functions, and it still gives me the same answer. So if I were to subtract 2 pi from this argument here, well, I would just get negative 2 theta. So r equals to 4 times the sine of negative 2 theta. And then again, the negative will come out to the front. Unfortunately, we can't see whether or not this has symmetry. It may, it might not. I mean, it's a rose with 4 petals, so it should have symmetry, but our ability to check for it is null. So what we're going to have to do is graph from the entirety 0 to 2 pi. Usually I like to graph at least 9 points when it's this big of a range, but you can graph less if you want. It won't be as detailed, or you can definitely graph more. Graphing more will definitely give you a very detailed picture. So I always like to start out. So of course I'm going to go ahead and start out with my first angle being 0. And then I'm going to get 8 other points. Well, the difference between 0 and 2 pi is 2 pi. So I'm going to go ahead and divide up 2 pi into 8 even pieces to make my life a little bit easier. This is going to give me pi over 4. So then I'm going to get my other angles by adding pi over 4 to the previous angle. So 0 plus pi over 4 is going to be pi over 4. Plus pi over 4 gives me pi over 2. And we're going to keep on going in this fashion. And there we have our 9 angles. And we're going to start plugging this into our function. So I'm going to have 4 times the sine of 2 times 0, which will give me 4 times the sine of 0. The sine of 0 is 0, and 4 times 0 is 0. So we get to plug in pi over 4. So I end up with 4 times the sine of pi over 2. Well, the sine of pi over 2 is going to give me 1. And 4 times 1 gives me 4. And of course, you can plug this in your calculator to get your answers. So for pi over 2, I'll end up with my answer is 0. 3 pi over 4, negative 4. Then 0, and 4, and 0, and negative 4, and then back to 0. So I'm not getting a whole lot of detail, even though I have 9 points. But it's going to be enough for me to be able to get my rows. So I start out at the point 0 for my angle and 0 for my radius. So right here in the middle. And I go to a radius of 4 into the angle pi over 4. So all the way out, pi over 4. And then I go back to 0. Then I have a radius of negative 4 and 3 pi over 4. So I'm going to go negative 4 and then go 3 pi over 4. So it's going to be down here. And then back to 0. Then I have a radius of 4 and 5 pi over 4. So it's going to be all the way over here. And then back to 0. And then negative 4 and a radius of 7 pi over 4. Which will bring me here. And then back to 0. We want to graph our rows in the same order that we plotted these points. I'm going to start out at 0, and we know our rows will come out, curve, and it's going to touch that point, and then come back to 0. Then it came down, touched that point, and then back to 0. And then over here, touch that point, and back to 0. And then over here, touch that point, and back to 0. And there we have our rose with 4 petals. Now, of course, you can see my rose is not the prettiest, so you can go back and fix it a little bit, but we're looking for just a general sketch of what's going on. So it doesn't have to be perfect. We just want to know exactly we just need to know generally what the graph of our function is doing.